Recording in progress.
Yeah, cam's on everyone. Let's start off. Great. So this was the last thing that we did. So today advanced results were out. I think we got around 1 second. Yeah, perfect. I think we got around 10 people below 10,000. So there is a big cluster at 1,500, 2,000, 3,000, 4,000. It is spread out. This time the cutoff was 92. If you got 92 marks, you are getting a last rank. Last year it was 80. This year we thought the paper was tough, but the cutoff still went actually little on a higher side. But anyways, so the kid who got 196, I think that's the score. So that rank was 1,500. I think the kid who got 176, his rank was 2,150 kuch to tha roughly. So if you see 50% score will still put you around 2,000 rank. Meaning it was same thing last year also. Same thing, 176 gave you around 1,900. 82,000 cast plus, so around 100, 150 ranks ka difference. But this is what I keep telling you. This advanced and all this stuff, right? No one expects you to score 90s, and yeah, people do. But as long as you put around 50% score, that's a very respectable score. So, anyways, so let's go ahead. So this thing, let's do one more before going ahead. So continue working. And the one thing I can tell you is this: always focus on your end goal. The problem is this, what I have seen with your seniors also, most of them are quite distracted with their weekly tests. Yeah, I know school card, class card tests are important, their marks are important and all, but at what cost? Meaning, one simple example I'll tell you. If a student comes and tells me, sir, this next week there is a major test. I don't know what to do. I have only 10 days to prepare. I tell them, okay, how many chapters are there in physics? He tells me, sir, there are like 8 chapters. 8 chapters I have to study in 1 week. Remember, there is physics and maths and chemistry also. I said, okay. Out of these 8 chapters, like in the next 1 week, right? How many chapters you can do thoroughly? I said, how many chapters you are thorough? Maybe like 3 or 4 chapters I'm thorough. Then I asked them, like, how many chapters you can, do thoroughly in this thing? Maybe 2 chapters in a week. Maybe you can do 2 chapters properly. Then I said, okay. Then see if you're good with 3 chapters, then do, the 2 chapters which are important, right? And the remaining chapters, you just leave it. He's like, sir, how can we leave something? I should do all 8 chapters. I said, okay, do you have time to do all 8 chapters? No. How many chapters can you do? 3 plus 2, you can do 5 chapters thoroughly. Then why don't you do the 5 chapters thoroughly? You're getting the problem there. They want to do everything, but you can't do everything. Now there is a dilemma. And you know what happens in the end? This kid, right, because of the dilemma, end mein, right, he doesn't even do that 5 properly. He will do 3 only. You're getting there. So don't become too greedy there. Classes mein thoda marks idhar udhar aayega, but keep your end goal. Now, what happens with this? Now, if this kid actually had followed and did only these 5 chapters thoroughly, next major test jab aayega, right? Then this time there'll be 12 chapters, isn't it? This will never stop. This will keep going up. Now the same question will come. I have 12 chapters to do. I have 10 days to do. What to do? Same question. How many chapters you can do? Well, I'm 5 chapters. I'm thorough. In the next 2 to 3 weeks or 2 weeks, how many chapters more you can do? Maybe you can do 3 chapters. So do 8 chapters thoroughly. I'm not saying ignore the rest, but at least whatever you can do, make them keep strong. Now this will go on till when? In physics, I think sub milake you have around 24 chapters. So by the time the portion gets over, if you come and tell me, sir, 16 to 18 chapters, I'm good. Only 5 to 6 chapters I need to work on. You're in a very good position. Most people don't do this. They're running behind that major test. right? Chalo, major test फिर भी you're running behind, I can understand, but these people want to every Sunday test, you are getting scared, rushed and tensed. You stop studying only. Problem is that you're getting it. So give subject the primary focus. What is the point of running behind marks when your subject is so bad? If your subject is not good, anyway, you're not going to score. So what people do, they panic. Oh, itna karna hai, itna karna hai, right? You have to do 10 chapters. You know, with the given time, you can do only 3 chapters. Then do those 3 chapters thoroughly, na? No, we don't want to do that three. We want to cry and crib like, oh, 10 chapter hai, 10 chapter hai, and anyway, you'll do only one chapter. Yeah, I think that's the thing. If you are careful with that, I think that will put you a big advantage. Always focus on your end goal. Your end goal is cracking the advanced exam. All your tests in the middle are fine. I'll tell you one simple thing. What is an exam basically? An exam is nothing but, it simply tells you how much you have studied in the or how much well you prepared in the test. The exam has no emotions. The exam doesn't tell anything about you. Let's say in an exam you score 90 out of 100. What does it mean? Means you simply prepared the chapter well. Why should you feel happy about it? You guys become happy about it. Let's say you score 10 out of 100. What does it mean? You didn't prepare the chapter well. You feel sad about it. Why are you feeling sad about it? The problem is that stop feeling happy when you get good marks, then don't feel sad when you get less marks. Take it very objectively. Exam is simply telling you how much you have studied and how much you have not done your work. The exam has no feelings for you. Exam is not judging you. Getting it? Exam doesn't care who you are. So you are the ones who are taking it emotionally and becoming emotion about it. You need to get rid of that. Exam mein marks important hai, yeah, but score a bare minimum at least and then continue studying. Focus on your subject. Marks will come as a byproduct. Then I was preparing it. I still remember. One day I and my friend had a doubt. What if we guess the whole paper? What will happen? We said, ठीक है, इस बार try करते. Let's go and guess the whole paper. Went to the exam, solved the whole paper, kept the answer sheet aside, took the OMR, started marking randomly A, B, C, D, just whole paper marked randomly. Getting it? And I got something like, single digit marks out of 270. And my principal asked, what happened? I said, sir, I did an experiment. I and my friend, we did this for 2 tests, back to back. The principal was asking, what are you guys doing? I said, we told him this is what we are doing. You guys don't do that. आपको लगता है हर test में you need to score. That is a problem. You guys don't want to do experiments. You won't. And what I realized, out of every six, every 6 questions, I'm getting only one question right. It is very clear. My luck with guessing is very bad. I should never guess. The second thing I realized, if I can eliminate two options, A, B, C, D, if I can eliminate two options, and if I mark between A and D, my probability of succeeding rate goes very high. That means whenever I eliminate two options, I should mark the answer. This is all data driven. There is no emotion there. You guys don't treat exams like it's a way to collect data about yourself. But for some reason, we feel like every exam we need to score really high. Score good amount of marks are cut off, but focus on your subject. I'm telling you, this is the long-term thing. I have seen people, right? They focus on this. But if you run behind marks every day, yeah, once in a while it is fine. But every test you run behind marks, you will compromise your subject. So just take it that from me. So you're still in the starting, but yeah, let's see. Dhruv, I can't see you, so it's a common phenomena with you for some reason. So we got a building there, we got a window here. So you took a stone here and you released from rest. So this stone goes and falls there. So this window is at a height of h. So the top of the window is at a height h from the top, and the width of the window is 2 meters. Or you can say height of the window, whatever you want to call it. All right. So the stone crosses the window in 0.2 seconds. So when you left the stone, someone is observing the stone through the window. So when the stone starts from point A to point B, that is this time, this is 0.2 seconds. Find H. H is the top part of the window from the top of the building. H is not the height of the building. So we have a building. Someone took a stone and left it from the top of the building. The stone falls down, and while falling down, it crosses a window somewhere down. We don't know where it is. The window of width is 2 meters. It crosses the window in 0.2 seconds. Using this information, you have to find H from the top till the top of the window. What was the distance? I hope the story was clear. Remember, I taught you only 3 equations. V is u plus at, S is ut plus half at square, v square minus u square is 2s. We are not doing anything new other than this stuff. Yukti, you have to type your answer. In the exam, you'll ask this only. Is it decimal? Is it integer? And then you'll type the answer. No, na? Hmm. Let's see. I don't know the answer, but let's see if anyone else gets Karthik. I think you both got the same answer. Yeah, that looks right. Karthik and Yukti. Right. You guys have some formula or something, yeah, for this. You got it so fast without any calculations. Or you may be calculating very fast. Good. Get the standard models. Any more answers? We have 2 answers so far. Okay, let's see. So take it like this. Let's say you're going from O to A. So let's call this point as O. So when you're going from O to A, remember I'm using the equation S is equal to ut plus half at square. The displacement is minus h. Velocity is 0. Acceleration is minus 10. Time, we don't know. So minus h is equal to 0 minus half gt square. That is half 10t square. This is one equation. So we get h is equal to 5t square. Perfect. Now when you go from O to B, the displacement will be minus of h plus 2. Speed is still 0. Acceleration is minus 10. Now this time, the time will be how much? Time will be t plus 0.2, isn't it? Whatever is the time from O to A plus 0.2 seconds. Dhruv, right. Shlok, that is wrong. You got an extra 10. That's it. Just substitute here. Minus h plus 2, u is 0, minus half 10 t square is t plus 0.2 ka square. Take h from here and substitute. Minus minus goes off. This is your equation 1. Substitute here. That would be 5t square plus 2 is equal to 5. This would be t square plus 0.4t. Yeah, actually there is no quadratic. It got cancelled. So I think that's why you got it fast. 5t square goes off. This would be 5 into, that's 2t plus 0.2. Yeah, that would be 1.98 by 2t. So from here you'll get the time. How much is this? Yeah, 1.8, sorry. That's 0.9 seconds. Great. Once you get this thing, put it in the first equation, h is equal to 5t square. Substitute here, you should get 4.05 meters. Yeah, most of you got that same. Easy. Clear with this? So take from O to A and take from O to B, and you get two equations, and you just solve them. Any doubts on this? Clear? Clear, na? Shlok, Rohit, Manav, Dave. Clear? Let's see one more like this. We got a building here. This is a standard mains or CET level question. Yeah, all these are mains are in bits level only. Nothing is advanced so far. 1D may there's very little they can actually ask at an advanced level. They will mix up 2 to 3 chapters, then things will come. But these are the basics. If you're not clear with this, then you can't go to advanced next. So the stone covers 9 by 25 of the total height. In the last second of its motion. Find h. So we don't know the height of the building. We don't know how long it will take to fall down. But let's say whatever is the time. For example, let's say time is 10 seconds. In that last 1 second, that means from 9 to 10 second, it will cover 9 by 25 of the total height. So what is the height of the building? The previous one is better than this, but yeah, they both belong to the same category. I hope the question was clear, the wordings and all. You release the stone from top of a building, it is falling down with increasing speed. In the last second of its motion, we don't know how much is the time. It covers 9 by 25th of the total height. And what is the height of the building? Any answers? I thought you guys would answer this faster than the previous one. Weird. You get a good number, get a good integer. No answers from anyone. What happened? People are tired today? Right, Yukti. Yeah. Let's see. Right, Dhruv. So we don't know the total time, right? So let the total time be t. So from here to here, when you fall, let the time be t. So this equation would be what? Displacement is minus h. This is your h. And the time is t. Now you're saying in the last 1 second, you'll cover 9h by 25. That means you covered 16h by 25 in t minus t, in t minus 1. Isn't that making sense? So if you cover 9h by 25 in the last second, that means you covered 16h by 25 in t minus 1 seconds. That is the interpretation there. So whatever is the total time from there, remove 1 second. And then you're done. So we are using the equation S is ut plus half at square. So minus h is equal to 0 minus half gt square. That's your equation 1. For the second one, it is minus 16h by 25 is 0 minus half g t minus 1 ka square. You're getting what I did? I wrote one for the red one and one for the green one. Solve this, you'll get t is equal to 5 seconds. I know the answer here. And take this and put it in equation 1, and then h would give you 125 meters. Then, if you got the equations, you are done. Easy. This would be a decent bits level question. They do ask, even at a mains level, out of 25, you will get maybe 10 questions of this level. All clear with this? Next one. This is another standard model. We got a tall building. When I say tall building, we can assume it will take a lot of time for it to reach the ground. First thing, find. And you drop the stone from here, release from rest. Find ratio distance traveled in 1 second, 2 seconds, 3 seconds, and so on. Ratio of distance traveled in first second. Look at the wording, it changed. Second. So this is different from the first one, and so on till nth second. 2 seconds and second are two different words. So I hope you remember that. Second meaning 1 to 2. The third one, if I have to ask you in the exam, I'll ask you the C part. The ratio of time taken to cover first meter, second meter, third meter, and so on. What is first meter? 0 to 1. If you go from 0 to 1 meter, it is first meter. What is second meter? 1 meter to second meter. Third meter is 2 meter to third meter mark. So yeah, be careful with the wordings there. So if you divide this whole thing into marks, 0 meter, 1 meter, 2 meter, 3 meter, and so on, they're asking how much time will it take to cover 0 to 1, time from 1 to 2, time from 2 to 3, and so on, and uska ratio. I'm more interested in C ka answer. So let's see. 1 and 2 are like, yeah, they have been asked so many times. So CED types. C is still a decent one. Get them all. I'll give you a minute or two. Anyone not clear with the question, didn't understand what I'm asking, please don't hesitate. Ask me, get it cleared. Yeah, that looks right. See, anyone else? Hana, that is okay. First one is fine. And give me the third one ka answer. I want only the third one ka answer. If you got the third one, I'll assume you got 1 and 2. Yeah, right, Prasha, you got all 3 right. Anish, you can simplify that further. Right? You got the answer, but exam aisa nahi aayega na. You could simplify it further. Right, Ahana. So let's see the first part. First part was easy. So we are using the formula S is equal to ut plus half at square. So here when it is falling, S is equal to ut plus half at square. S will be minus h. Your initial velocity is 0 and minus half gt square. And there, so we got h is equal to half gt square. So this is the height fallen in time t. So in 1 second, how much will you fall? In 1 second, you will fall half g1 square. In 2 seconds, you will fall half g2 square. In 3 seconds, you will fall half g3 square, and so on. You got the sequence here. So for the first one, the answer would be half g1 square is to half g2 square is to half g3 square, and so on. So the answer is 1 square, 2 square, 3 square, and so on till n square. What's the next thing? You want in the first second, second second. So this would be the first second, 0 to 1. This difference here is your second second. The difference between 3 and 2 is your third second, and so on. So basically, you have to subtract them. So for the B part answer, it is half g 1 square. For the second second, it is half g 2 square minus 1 square, half g 3 square minus 2 square, and so on. So basically, you take the next guy and this one and subtract them. You'll get 1 is 2, 3 is 2, 5 is 2, so on until it's an odd numbers, 2n minus 1. All clear with this? The third one. Here, the answer is here only. You want time, right? You don't want height. So time will be how much? Root over 2h by g. So this is the time taken to fall a height of h. So for the first 1 meter, so if you go from 0 to 1 meter, the time taken, let's call it t1, which is root over 2 into 1 by g. 0 to 2 meter, let's call it t2. So this is the time taken in 2 seconds. Because see, this formula is from the top, root over 2 into 2 by g. 3 meters when you go from here to here. So you'll get T3, which is root over 2 into 3 by g. But I'm not asking you this. I'm asking you time interval between 1 meter, 2 meter, and so on. So what I'm asking you is T1 is to T2 minus T1 is to T3 minus T2, and so on. Substitute here. So this would be root over 2 into 1 by g, root over 2 by g, and you will see there will be root 2 minus root 1. If you just take out root 2 BGB common, you will notice this root 3 minus root 2, and so on. So this would be, you can write like this, root 1 minus root 0. Yeah, it's root 1 only. Just to show you it forms a good sequence. Root 3 minus root 2, root 4 minus root 3, and so on till root n minus root n minus. Clear with this? So it's the next number and the previous number, cut roots and subtract them. That's why I said this thing is a decent one. Any doubts on this? So be careful between the distance traveled in time taken for 1 meter, time taken for 2 meter, time taken for 3 meter is different from time taken for first meter, second meter, third meter. Did you see that one thing, right? First meter and 1 meter, 2 meter and second meter, the whole answer will change. All clear with this stuff? Great. So far we dealt with all this constant stuff. So let's change it a bit. Let's
So
say we
can
got a
you
rocket.
show the final answer for the C part once again?
B part, this one, 135.
No, no, C1, C.
It's here only.
Okay,
Clear?
okay, thank you, sir. Yeah.
So we got a rocket here whose acceleration is a is equal to t. T is time. So this rocket, right? Acceleration is not constant. A rocket has acceleration a is equal to t. Matlab t is equal to 1 second, your acceleration is 1 meter per second square. T is equal to 5, your acceleration is 5 meter per second square. So as time increases, your acceleration is increasing for 10 seconds. So the fuel gets over at 10 seconds. So after 10 seconds, the engine shuts off. So this equation A is equal to T is valid only for 10 seconds. Find H max and the total time of flight. Find H max from ground level. So initially it is at the ground. The total time in air. So that is including the first 10 seconds. Find total time the rocket is in air. Yeah. Now you can't use your the three equations because A is changing. But once the rocket engine shuts off, what do you think will happen? Will the rocket just fall down? This question is similar to this balloon problem if you remember last time. You will have the same velocity at that instant. So try. Numbers are not that great, but yeah, we can do this. Find the maximum height the rocket reaches and the total time the rocket is in air. $1750 by 6. I don't know the answer. 500 by 3 plus 125 could be right. Maybe the same thing, I guess. Yeah. Get me the time. Okay, 1750 by 6, I think. Yeah. Two people got it, the and Sumana. So maybe right. Okay, let's see the first part. I think, yeah, people are getting the height part right. So let's analyze this. How do we do this? You cannot use the three equations anymore because your A is changing. So we have the rocket here. This is T is equal to 0. So for 10 seconds, you're accelerating. So the rocket must have gone till somewhere here for T is equal to 10 seconds. The rocket is here at this instant. Great. Go back to calculus. A is equal to T. So what is acceleration? dv by dt. This is the standard result. Integrate. We get v is equal to t square by 2. I'm skipping steps. Right? So you want, I can write it down actually. dv is equal to t dt. Limits. You're starting from rest. 0, v, and t. So this will give you v is equal to t square by 2. Integrate again. dy by dt. I'm writing y coordinate because it's height anyway. So t square by 2. This would be dy is equal to t square by 2 dt. Limits, again, you're starting from 0. to t. This would give you y is equal to t cubed by 6. So these two are our main equations. All this is valid only till 10 seconds. This is all valid only for 10 seconds. After 10 seconds, you can't use these equations. Perfect. So at t is equal to 10, your v will be 50 meters per second. And your y coordinate will be 1000 by 6 or 500 by 3. So the rocket, when the engine shuts off, it gained a speed of v is equal to 50 meters per second. So the rocket is not at rest. And you reached a height of 500 by 3 meters. At this point, now what will the rocket think? The rocket will think, okay, the fuel got over. Now at this point, it will start flying like a projectile. It will still go up because you still have velocity. And then you will return back and fall on the ground. That story is clear. So once the engine shuts off, the gravity will start acting. So it pulls down with minus g. So that means the engines were so powerful, they are able to oppose the gravity and give you that acceleration. If the engine shuts off, you'll start going down with minus g. So if the engine shuts off, a becomes equal to minus g. So after the engine shuts off, suddenly your equation becomes your regular kinematics problem. So I can convert this problem like this. So this whole problem looks like this. We got a building whose height is 500 by 3 meters. See, this is the main thing. Huh? You did something and then you should be always able to relate. Hey, this is looking like that problem. And someone threw a particle with a speed of 50 meters per second. Now, indirectly, I'm asking you what is h max and what is the time of flight. And we know how to do this question. What is h max here? So h max is v square by 2g. But remember, this is from the top of the building. That would give you 125 meters, 2500 by 20. Perfect. So the total height will be how much? The total height from ground level will be 500 by 3 plus 125. You can add it. I will leave it to you. Next thing, what about the time of flight? We are using the equation s is equal to ut plus half at square. But remember, this is the time taken from the top of the building to the ground. This is minus 500 by 3. U is 50t minus 5t square. You get a quadratic 5 O's of t square minus 10t minus 100 by 3. Numbers are not that great. So t is equal to 10 plus root over 100 plus 400 by 3 by 2. That would be 5 plus 10 root 7. That's 700. 7 by 3, that is 10 by 2, that becomes 5. I skipped a lot of steps, so please make sure to check it out. So that's your time from the building. What you want is the total time. The total time, the rocket were on for 10 seconds, plus this t. That's 15 plus 5 root 7 by 3. Check. Got the same? Yeah, you can simplify it further, but you don't get any good integer. So all clear how we did this thing. So the first part of the problem is calculus, which you know how to do, right? And if you think like, oh, this is looking new, this is not new. Wasn't this the question? A is equal to t? Exact same integration. Page 143, calculus. There, so we combined two different things. See how we combined a calculus problem with a standard problem. All clear with this? Clear? Let's see one more. This would be a good problem. At your current level, this will be a good advanced problem. We have a particle projected with speed u. And you can take this thing as y is equal to 0. So y is the height from the ground level. And you have this is a weird planet whose acceleration a is given by minus g naught of y. And you look at this planet, when y is 0, there is no gravity. As you go up, the gravity is increasing. and this g naught is some constant. So the higher you go, the more gravity you have. So this guy is going to come back. Unlike that problem where gravity was decreasing, you had an escape velocity. यहाँ पे escape velocity नहीं होगा. Because as you go higher and higher, the gravity becomes so strong, eventually you will come back. This is hypothetical, but yeah. So particle is projected vertically. With speed u. First thing, find h max. Find the velocity and the height as function of time t. Actually, if you do b part, a part भी आ जाएगा. Do the b part. Without b, you only take. Find the velocity and the height at time t. Find time of ascent and time of flight. This is a really good one. At your level, this will be a good advanced question. Even at the actual advanced question, this will still be somewhere at a moderate level. Frankly speaking, this is more of a max question than physics. So try. So you can't use your regular equations. All that formulas are gone. H max, u square by 2g, all that stuff. You have to go back to your integration. The minus sign simply indicates it is downward. So that's it. So don't really worry about the meaning of minus sign. Negative indicates direction. Let's see how will you do this then. Try. I'll give 2-3 minutes, then I'll show you. You will need this integration in case you don't remember. Dx by root over a square minus x square का integral is given by sine inverse x by a. You will need this integration. So there. This we did in integration by substitution, but ठीक है. Like I said, every time they come, I'll show you, at least for next few months.
Sir, y is a variable now.
Yeah. Y is the height from the ground. So height from the ground is changing. In case you're wondering how to start, I'll tell you what I think. Okay, a is equal to g naught by a is not constant. Great. I can't use my equations. Clear. Then what can I do? I have to integrate. इतना तो clear था. Now a के लिए there are only two formulas. A is equal to dv by dt or a is equal to v dv by dy in this case. Which one to use? Can I use the time one? No. क्यों? यहाँ पे time तो है ही नहीं. So the only thing left is that y1. So I have to use this and integrate. Now I don't know what will happen, but I know that is where from I should start from. So I'll start with that and I'll see what will happen after that. You're getting how you think? See, that is how you think. You see a question and you get stuck and you're wondering what to do. You have to ask yourself, what do I know? What can I use? So what is left? And then you do it from there. Root u square. That is h max. Yeah, you right. Got it right. Prisha. Get the rest. Get me the time of flight and time of ascent. So if this comes in the exam, I would ask you h max and time of flight. That will be two questions in advanced paragraph, at least at your level right now. नहीं युक्ति. What did you get? Uy minus gy cube. No, you goofed up something big time. You need to give me height as function of time, right? Why are you giving in terms of y? What you got was in terms of y. What I want is in terms of time. U sine root g naught by root u cos root g naught by. I'm confused, Prisha. What did you give exactly? Did you find the velocities? क्या? That is the B part का answer है suppose. हाँ. Yeah, I think they are right. नहीं रे वही बोल रहा हूँ युक्ति. B में I asked you to find with time. You're finding with Y. Let's see the first part, everyone. So like I said, how will I think? One thing is clear. The moment you see the question, इतना तो clear है boss. ये तो calculus based question है. You can't use the three equations. See, that's it. That is how you should think. You know, you don't go there and suddenly start doing some PhD level research. So I need to integrate. So A is equal to minus G naught Y. A has only two formulas, dy by dt and v dv by dx or dr. I can't use dy by dt because there is no time anywhere. So I will write this is vy dvy by dy. Everything is in y. So this would be vy dvy. So keep all y's on one side and keep all velocities on one side. Integrate this. When the velocity is zero, velocity is u. Be careful the limits. When this is y, this is some vy. Integrate this on both sides. So maybe if you want, I can remove the subscript also, but yeah. Vy square minus u square is equal to 2 is equal to minus g naught y square by 2. So this will give me Vy is equal to root over u square minus g naught y square. Remember, this is a velocity with y. I didn't ask you this. But yeah, it's still a good result. This is the velocity with height. We will need it. Now, when you reach h max, what will happen? When you reach h max, y is equal to h max, your velocity becomes 0. Vy becomes 0 at h max. So substitute here. So 0 is equal to root over u square minus g naught. This will be h max ka square. So this will give you h max directly from here, which is u by root g naught. Is that clear, everyone? That's your first part. Now for the second part. Now I know Vy is equal to root over u square minus g naught y square. Now you want to find in terms of time. So let's write this thing as dy by dt is root over u square minus g naught y square. Then we have to integrate this. This will be dy by root over, take out the g naught common outside. Then this will be root over u square by g naught minus y square is equal to dt. Let me show it in the next page. So you want to integrate this guy 1 by root g naught integral dy by root over u by root g naught ka square. You have to manipulate it a bit. You have to just write it more carefully. Integral dt. Why am I doing all this thing? The reason I'm doing all this is because if you remember the formula, integral dy by root over a square minus y square or x square, whatever you want to call, is sine inverse x by a. So I want to write in this form. Now in this form, observe karo, x square ka coefficient is 1. So y square ka coefficient is 1. So this guy is looking like a. What is a? U by root g naught. So you have to write that exactly in that form. So y ka place mein we have x and a ka place mein we have this guy. So there, now substitute that formula here. 1 by root g naught, that will be anyway outside, and this guy will be sine inverse x. X ka place mein we have y by a. A is u by root g naught. There, that's your formula there. Is equal to time 0 to t, 0 to y. Substitute the values here. When you put a y, you will get 1 by root g naught sine inverse root g naught y by u, and sine inverse 0 is 0, and this is time. So arrange the terms here. We will get sine inverse root g naught y by u. Now see, this looks big and scary. Understand one thing. Don't get confused between a tough question and a lengthy equation. This is lengthy. It is not tough. You already know how to integrate. I gave you everything that is required. It is just a matter of writing the equations and brute force. You have to just keep solving. You can't get lazy. Most people get irritated looking at the equation, they get scared. But frankly, if you see, we are doing nothing interesting or nothing intellectually something here. Brute force, you're just putting the formulas and just simplifying it. This is root g naught y by u is equal to sine root g naught t. There we got y. Y is equal to u by root g naught sine root g naught t. This is your y coordinate as function of time t. You want velocity? Differentiate this. So Vy will be dy by dt. That would be u1 g naught cos root g naught t. नहीं ये cancel हो जाएगा. Check your answers. This would be your y coordinate and this would be your velocity as function of time. These are different from this. This is velocity as function of y with height. Have a look at the steps. All clear with this? Just brute force integration there, nothing much. Any doubts on this? Anish, Shahna, Dhruv, Shriya, Soumya, Yukti, clear with this? Tanmay, Shlok. Then the third part. So once you got this, the y is equal to uy root g naught sine root g naught. If you see it's an interesting function, that means this particle is actually going up and down non-stop. This motion is called an SHM, simple harmonic motion. So there's a name for this. But anyway, that we will see later on. So this guy is going up and down. So look at the motion here. So it goes up, it comes to rest, Vy is 0. Then it turns back and comes back again here. So when do you get Hmax? When y is equal to Hmax, then time will be time of ascent. So if I substitute Hmax ka formula here, I'll get time of ascent. And when you come back to the ground level, y is equal to 0, then the time will be time of flight. Or I could have taken even Vy and I could have done that also. It would work. So Vy is u cos root g naught t. Perfect. At Hmax, Vy is 0. This implies that inside whatever is the angle must be 90 degrees. So therefore, root g naught t must be pi by 2. Therefore, the time of ascent is pi by 2 root g naught. Right, so this angle 90 degrees for pi by 2 radians. What about time of flight? For time of flight, y coordinate will be 0. So sine root g naught t is 0. Now there are two possibilities here. Root g naught t is 0 or root g naught t is equal to pi. T is equal to 0 is obvious. That is your starting position. See, Max doesn't know, right? Max is simply giving you all the times when you're at the origin. This is the initial position. This should be the time of flight then. This is the second time you come back to the ground. And you can see here by symmetry, time of flight and descent are same here. Pi by root g naught. So while going up and coming down, if you have same acceleration profile, listen to this word. Let the acceleration change. But while going up and coming down, if you have same acceleration at that particular position, for example, while going up, here acceleration is 10, here it is 9, here it is 7, here it is 3, here it is 2. While coming down, here it is 2, here it is 3, here it is 7, here it is 9. The time of ascent and time of flight will be same, descent will be same. But while going up and coming down, if you have different accelerations, like this question which we did last time. Remember this question, air resistance? While going up, it was 12, and while coming down, it was 8. If your acceleration while going up and coming down, the profile is different, meaning at every position, if your acceleration is changing while going and coming down, you will not get the same time. Time of ascent was 5 by 3 and time of descent was 5 by root 6. You're getting it? So that's a, you understand that you can actually say double of this, the question gets over here. In the exam, it saves you time. Any doubts on this? You should definitely do this on your own again. If you found it like, oh, what the hell is happening? Ask yourself. Physics got over here, isn't it? Once I wrote A is equal to V dV by dy, physics got over at that point. After that, there was no physics anywhere. Matlab, H max mein Vy is zero. So that basic stuff is there. The whole problem is more of max. And the only way to learn this is take a paper and just try to solve the whole thing without looking at it. You will get stuck. Struggle for 4 5 minutes and then come back and see it again. You don't do that. You just read it like a novel. This will not go into your head. Is this clear, everyone? Let's see one more like this. We'll ask an easy one. Let's say we have a particle here going with u. We have an acceleration a is equal to minus kv square plus g. This will become too much, I guess. Yeah, this will become too much. You also have a gravity. So you have both. This is due to air resistance. This is your additional acceleration due to air resistance. In reality, this is how air resistance works for spherical bodies. If the body is a perfect sphere, the air resistance is proportional to minus v. The faster you go, the more deceleration you have. But if the objects are not spherical, then the value can change. You'll get a is equal to minus k v power 1.5 v square and so on. One of the big problem, bullet trains face. When you are going faster and faster, when a bullet train goes from 0 to 300 kilometers per hour, and a 300 to 350 kilometers per hour, it takes the same amount of power. Just to increase that extra 50 kilometers per hour, you have to give the same energy as 0 to 300. So yeah, it gets pretty inefficient. So yeah. So this particle goes up and comes down with speed v. So we have more information here. The particle is projected vertically with u in presence of air resistance. It comes back to ground with speed v. Now see, don't get confused between a tough question and a lengthy question. I keep telling you this. You will find questions, right, which are tough, meaning you will see the question and you will think like, what the hell to do? It is difficult to figure out, but once you figure out, it takes very less time to solve. The second type of question is easy, but it is tough. It is lengthy to solve. The previous one was a easy question, which was lengthy to solve. You might think like, oh, sir, easy question. It was easy. Concept-wise, there was nothing there. It was lengthy. So you need to have the distinction. Don't get confused. If you don't have the distinction, you will start panicking like, oh, something is gone. This is a question which is tough but easy to solve. Sometimes you're unfortunately tough and lengthy question both will come. That happens in advance. Maybe around 30-40% questions are like that. Then there is nothing. You have to just keep your mouth shut and just keep solving as fast as you can. Find time of flight. You projected a particle with speed u. There is an air resistance. There is also a gravity. Both are there. The air resistance is giving you an acceleration A is equal to minus kV. K is some constant. So the faster you go, the more air resistance you have. So that acceleration is coming with speed. Think about this. This thing, right? Normally, if you have not seen this before, it's difficult to solve. But take a minute or two. Now, if you're unable to figure out something, right, just do brute force and just see how much hopeless equations you'll get. Just try a brute force equation. So what will be the net acceleration? I'll do one thing, just to give a subscript, let's call this thing AR, air resistance. So net acceleration will be how much? Minus kV, minus G. Both are downward. So that is your net acceleration. So if we try to integrate this will put dv by dt, and then we try to integrate this, we'll get a ln ka term. It's a mess. Listen, I'll show you this thing. This is a good one. You projected a particle with speed u, you go up, and then you come back with v. So that's fine. You don't get an idea now, but once I show you, next time something similar comes, you will see similar techniques. Then you should know, I have to do like this. What is the net acceleration? So since you're going down, the net acceleration is, let's say when the particle is going up, take any one scenario. If it is going up, then the air resistance will be down. So then acceleration will be minus kV and minus g. This is the air resistance ka acceleration. And this is your regular gravity. So both are pulling down. And don't worry about the signs, okay? When the V will reverse, the sign will change. V will become negative. So the signs will take care of themselves automatically. But anyway, I'll write it in vector form. So A is equal to minus kV bar and minus g bar. Everyone agrees with this equation? नहीं रे प्रशा. What did you get exactly? Did you get time of ascent? Kya? That's time of flight, you're saying? How did you get that? What did you do? Tell me. You can just unmute and say.
First, I remove the time to go up and then time to go down. So for when it goes up, the acceleration will be minus.
The acceleration कितना होगा? Minus kV minus g, na? You did this thing dv by dt, right?
Yeah, and then when it comes down, it will be g minus kv.
So kV plus g, then you wrote minus dt, then you integrated this. And then you got some time there. And while coming down, you wrote kV plus g. You did that brute force. Then you took 0 to v, and then you added them. Interesting. Okay. I didn't about it. Okay, let's see. We need to see. Maybe now look at this thing. So I can write acceleration is equal to dv by dt. This is minus g bar. Send that dt that side. This will be minus dv bar. This is minus kv bar dt minus g bar dt. Right? Now we integrate on both sides. dv bar minus k integral v bar dt minus g bar is constant anyway, so I'll just push it out and integral dt. Now listen to this thing. When you integrate on both sides, now I don't know how to integrate this, but let's try to understand the meaning of this. When the time is 0 to time of flight, 0 to time of flight, when the time was 0, what was the velocity? U, upward. When it is coming back, what was the velocity? Minus v. Do you guys agree with the limits? Vector, right? While going up, it is u j cap, and while coming back, it was minus v j cap. Clear? So, what is vdt? What is integral vdt? Isn't this displacement? Velocity into time is displacement. Now you tell me, if you start from the ground and come back to the ground, what is the displacement? Zero. That term becomes zero. I don't know velocity, I don't know time, but I know velocity into time is displacement. So you went and came back to the same place, the displacement is zero. So this term would be v bar, limits will go from minus v to u. This term became zero, and this will become minus g t. Time went from zero to time of flight. Substitute the limits there, you will end up with minus v minus u is equal to minus g time of flight. So that would give you time of flight is equal to v plus u by g. Did you see what we did? Was it easy to solve? It was easy to solve, but figuring out that I can do like this is the tricky part. And this is a very special case, okay? If this is a is equal to minus kv square, you can't do this. Because what is integral v square dt? Nothing, isn't it? There's no meaning for this. Just because it is v bar, you got this. Now we need to see Prisha about something. So we got in lawn, we got such a good answer here. So what went wrong? Yours still looks right only. But yeah, I think, Prashad, did you notice one thing? In your answer, there is a K everywhere. I don't have a K anywhere. I think maybe if you can find that K somehow and put it in your answer, you should get this. So I think you're not wrong. Your answer was right if it is in terms of K, but agar options if you only have V and U and G, then that won't work. So maybe that is the case, I guess. Is this question making sense, everyone? So remember, this thing worked beautifully just because A is equal to minus KV power 1. If it was anything else, this method wouldn't have worked. So this was a kind of a question which was tough to figure out, but once you figured out, it takes less than a minute to solve. All clear with this? Any doubts on this thing? Please ask. It's a pretty good one. Clear? Go take a break. Come back by 9:45. We'll continue from here. And there you can see how the variable acceleration problems are. Yeah. Come back by 9:46. Yeah, let's start off. Great. So what we have seen so far is all 1D. We've seen things going up and down, seen things going left and right. The next thing, what happens if you throw at angles? Projectile motion. So what's a projectile? A projectile is simply Particle projected at an angle theta with respect to ground. Yeah, that is the thing most of them we study. But if you take it more technically, right, where theta is not 90 degrees, you can actually generalize it in a much better way. You can say like this. Because every time the gravity won't be always down. Later on, we will see the acceleration could be in any direction. If your U bar and A bar are not parallel or anti-parallel, we can say the motion is projectile. That's a more better definition actually. But in all books you will see that because most of them we are throwing from ground level. Should not be parallel or anti-parallel. So basically angle should not be 0 or 180. So keep that in mind. So if you see the acceleration and the particle having a different acceleration, then it's a projectile motion there. So U bar and this is some A bar. And A bar should be constant. You should have a constant acceleration, direction, and magnitude. So what you're indirectly telling me is what would happen if I throw a particles like this? I don't know. You're getting it? So that is the most important thing. When you see things, right, most of the times the first thing answer is I don't know. And then you'll say, okay, I don't know this, but what can I do with this? Now in physics, right, we have one very important, I won't say concept, but it's a fundamental thing. We call it principle of superposition. So what this thing tells you, right, principle of superposition, if you have two independent events, let's say you have event 1 is creating effect 1. If event 2 is creating effect 2, and let's say both the events are independent of each other, when event 1 plus 2 will occur at the same time, you get effect 1 plus 2. Let me show you with an example. Let's say we got a block here, and let's say you're applying force F1, mass is m, and let's say acceleration is a1. Let's say we have a block m here, and let's say you're applying a force F2, and you have an acceleration a2. If you apply F1 and F2 at the same time, you will get an acceleration a bar, which is a1 bar plus a2 bar. So if you have two independent events, if event 1 creates effect 1 and event 2 creates effect 2, when you have both together, you get effect 1 plus 2. And this thing is not only just in motion, you can apply it anywhere. For example, let's say you have a circuit like this. Let's say we got a battery here. We got two batteries here, like this. Let's say this is resistance R1, R2, R3, and this is voltage V1 and V2. And this is actually how you teach computers how to solve computer circuits, right? So what we tell the computer, right? We'll say, okay, assume only V1 is there. So the computer will draw the circuit like this. So it will assume V2 is not there. It's a wire. R1, R2, R3. Then we will say find the current. So this will find the current, let's say I1, because now it is everything is series parallel. Then we'll say assume only V2 is there. So we'll assume V1 is a wire. And now again, we'll tell it to find the current. And let's say this time we got a current this way, which is let's say I2. The total current in that middle branch will be, so I3 is coming from the, I1 is coming from the top and I2 is going up. So the current in the middle branch is I1 minus I2. You're getting this logic? So if only battery V1 is there, what is the current in R3? I1 downward. If only V2 is there, then what is the current in the middle R3? I2 upward. So if both are day together, we will get I1 minus I2. You can see this is like a universal principle. It works multiple places. The only thing, both the things should be independent. V1 and V2 should not interact with each other. So that's it. So as long as this is satisfied, you can apply it across multiple chapters. Very powerful thing. We will use this in waves. We will use this in circuits, motion. Yeah, comes at multiple places. So we do something similar here. I don't know how to study if you throw at angles, but I know how to study if you throw up and down or if you throw left and right. So let me use that logic. So we study projectile motion by resolving the motion along two perpendicular directions. Now, since you resolve the motion, these will become two 1D motions. These are two one-dimensional motions. Which we know how to study. Then add them, whatever you do, and do all the analysis. And then whatever results you get, then add the results vectorially. So the name for this thing, right, is called the principle of superposition. This is not only to this, it's a very generic thing, but a very powerful thing. It really helps you to study a lot of things, where you cannot study the whole thing, but you can study each piece. So I can do that, and then I can combine that, makes your life easy. So this is what we do. So this is x-axis, this is y-axis, right? The particle is projected with u and theta. So I will split this velocity in the horizontal direction. So this will be ux meaning initial velocity in the x direction, which is u cos theta, vectors everyone. This is your uy, which is u sine theta. This is the vertical direction. The acceleration, the vertical direction is ay, which is minus g. So the subscript indicates a is acceleration, y means in the y direction. Ax is 0. Horizontally, there is no acceleration on the planet. At least now, later on you will get it. There is no horizontal acceleration when you throw from the ground. So we can split this. So ux is u cos theta. So this is your initial horizontal velocity. Initial vertical velocity. Great. So now what I'm suggesting, let's split this motion into two parts. You divided everything in x and divided everything in y. So this thing feels like as if someone threw a particle up with uy. This guy will go up and will come down. And the gravity is g. This you know how to study. Plus, the particle is projected horizontally with ux, which is u cos theta. Since there is no acceleration, it will just go in a straight line without doing anything. It will just keep going straight. There, if you understood this page, right, you got everything. You know how to do projectile. So this talks everything that happens in y direction, this guy will take care. Everything that happens in x direction, this guy will take care. So when you study about x, don't worry about y. Whatever happens in x does not affect y, and so on. What will be the equation? Sy is equal to uy t plus half ay t square. Since you're writing everything in y direction, I'll put a subscript y. So sy का place में you'll get y, uy का place में u sin theta, t ay is minus gt square. You want velocity? Vy is equal to uy plus ayt. Vy, what is u? U sin theta minus gt. There, you got everything in y direction. You got the y coordinate with time, you got the velocity with time. Maybe I'll just write this in blue. What about x direction? Same equations. Sx is equal to uxt. I'm just playing with the three equations. Only I'm writing x and y to explain that. Sx will give you x coordinate. This will be u cos theta into t. Ax is 0. Now it is 0. Later on, ax won't be 0. Then you have to substitute that. Horizontal velocity, Vx is equal to ux plus axt. Vx is equal to ux. The horizontal velocity does not change. There, you knew everything here actually. If you know your velocity and if you know your position at any time t, that means you know everything about the motion. Are these equations clear, everyone? Understood how we approach this thing? Instead of seeing that curvy thing, you split them into two things. Now, if you combine them back, see what will happen if you combine them. So this thing which you projected with ui, this guy, u sine theta. So this thing goes up and comes down. So this is a very important thing. So when you see something complex, instead of trying to solve the whole thing, try to solve it in steps. So if you find the times at different things, let's say this is time t1, time t2, time t3, time t4, time t5, time t6, and time t7. Let's say you have taken 7 different points, t1, t2, and so on. So the same thing, it will be t1, t2, t3, t4, t5, and t6, and t7. So basically, this is giving you x coordinates and this is giving you the y coordinates. Now, if you try to plot a graph, so t1, x coordinate is 0, y coordinate is 0. So you'll be somewhere here. T2, so you'll get like this. I'll just draw the path first. This is how it will look. So this point will be T1. You'll get x and y from there. T2 will be somewhere here. T3 will be somewhere here. T4 is the H max. T5 will be somewhere here. T6 will be somewhere here. And T7 will be somewhere here. Making sense what we did? So by finding, let's say put 1, 2, 3, 4, so on, get 100 points there and 100 points here. And just if you put a graph there, now you get a path. So this motion is giving you the y coordinates of this path, the curvy path, which I don't know how to study, but now I know, right? And this will give you the x coordinates. What about the heights? This would be the h max. So if this is h max, that means this is also h max. So everything that happens in the y direction comes from the y coordinate. So what is the h max for a projectile motion? uy square by 2ay. Do you remember this? I told you this is a better way of writing. What is uy? U square sine square theta by 2g. Who takes care of time? The vertical or horizontal? The vertical, isn't it? How much time it takes to go up and down will depend only on the vertical component. So time of light is 2u vertical by a vertical, which is 2u sine theta by g. What is time of ascent? So literally everything you studied in 1D, all those formulas are valid here. Time of ascent is uy by ay. So you can simply reduce sine theta by g. Time of descent, u sine theta by g. Again, be careful. These two formulas are valid only when you come back to the same level of projection. What do you mean by that? If you're throwing from buildings, you can't use this formula. So if you throw like this, or if you throw like this, not valid. Don't use the formulas here. Same thing. The regular formulas are valid only when you, throw them from the same level. You have to come back to the same level. If you're throwing from buildings, you can't use these formulas. So literally everything you did in 1D is valid. All clear with this page? Any doubts on what we did? So whatever happens here up and down, the same thing happens here up and down. The y coordinate of that is a y coordinate of this, and so on. So what about the horizontal motion? Bit of a theory. There's the important part. So, but once you got the theory part, then we have some good problems. So when you throw with u and theta, this particle goes there and lands somewhere on the ground. This thing is called range. The range is the horizontal distance traveled by the particle in time of flight. Remember, Ax is 0 here. And we have a bit of a theory there. Great. So what formula should I use then? Sx is equal to uxt plus half axt square. So fx will be range. I'll use the symbol r. Ux is u cos theta. T will be time of flight, and this ax is 0. But what is time of flight? Just now we derived it. U cos theta, and time of flight is 2u sin theta by g. And what is 2 sin theta cos theta? Sin 2 theta. U square sin 2 theta by g. This is your range. Again, remember, this is valid only if you come back to the same level of projection. Meaning you can't use this formula when you throw from buildings. For that, we have ways to do, but we'll see that in the next class. So if you throw like this, so this is the range. The formula is not valid. Because this formula was derived under the assumption T is 2u sin theta by g. And 2u sin theta by g was derived under the assumption we came back to the same level. All clear with this? I'll put down all the formulas at one place, so don't worry. But listen to me and try to grasp. So this thing gave you everything up and down. This thing gave you everything left and right. Now here, if you look at the formula there, a little more on that, r is equal to u square sine 2 theta by g. You can clearly see here, theta and 90 minus theta will give the same range. And theta 45 gives maximum range. So if you want to actually throw something really far, you should throw at 45, neglecting air resistance. Yeah, but in real life, I think it should be slightly more than 45 because there's an air resistance. So what this is saying, for example, if you're throwing at 30 degrees, you'll go and fall somewhere here. 90 minus theta is 60 degrees. So if you throw at 60 degrees, you will go higher, but you will come and fall at the same place. You get the same range. Yeah, if you throw with the same speed, but different angles. And theta 45 will give you maximum range. So 30, 60, 15, 75, all these guys will give same range. In a computer, there is a game called Pocket Tanks. Anyone played it? You get a small tank, you can adjust your angles and everything, and you have to shoot, some bullets and hit the enemy ka thing. I think nowadays mobiles may have all these kind of games. But when we are in IT, it's one of the game we used to play a lot. Putting angles and shooting down your friend, it feels fun, isn't it? So, anyway, that is one thing. The next thing, equation of trajectory. There's a lot of things here, but all are connected. We'll finish off the whole theory at one go. What is the trajectory? The path. What is the equation? So we are going to find what is the equation of this. So what are the coordinates? So when you throw a particle here with speed u and theta, so this thing goes in the air and falls somewhere here. At any instant, this is your x coordinate and y coordinate. The x coordinate is x is equal to u cos theta into time. We derived it. Y is equal to u sin theta t minus half gt square. So from the first equation, get the time from here. T is equal to x by u cos theta. Take that and put it in the second equation. Y is equal to u sin theta, x by u cos theta. You need to remember all these formulas, like they will save you time in the exam. If deriving them will take time. U square cos square theta. Simplify this, you end up with y is equal to x tan theta minus gx square by 2u square cos square theta. So when they say equation of the trajectory, it is a relation between x and y. And interestingly here, if you take out x tan theta common, you can verify this on your own, you end up with 1 minus x by r, where r is the range. This is the two forms of the equation of trajectory. U square sine 2 theta by g. And this equation is actually a parabola. So the shape which you're seeing whenever you throw a particle into the air is a parabola. You guys remember paraboloid, the three-dimensional thing which you said? This is a two-dimensional thing, parabola. All clear with this? So you took x coordinate, y coordinate, eliminated time, and we got this. The next thing, the velocity profile. How does the velocity change when this particle is flying? Velocity and acceleration profile. So think about this. So when you're throwing, how is the velocity varying? Look at the horizontal velocity. Horizontal velocity ux is u cos theta. Since there is no horizontal gravity, no matter where you go, the horizontal velocity will always remain same. So if you actually throw a particle, you will notice horizontally the speed never changes. You're always going with u cos theta in the horizontal direction. Yeah, in real life, you have air resistance. So it's not true, but in vacuum, it is. If you look at the vertical direction, this will be like u sine theta. Here, the velocity would have changed, which is vy, which is u sine theta minus gt. So as you go up, the vertical velocity is changing. At the highest point, vy is 0. Then your vy becomes negative. And then when you come back with the same speed, but in the opposite direction for u sine theta. And what about the gravity? The gravity is always down. No matter how the particle is going up or down, the gravity will always act down. That is your velocity profile. So when you throw a particle into the air, the horizontal velocity remains same and the vertical velocity will change. So let me put down all these things. So the velocity vector v bar is given by vx I cap plus vy j cap. What is vx? U cos theta. What is vy? U sin theta minus gt. 'Clear? . 'Clear? 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 'Cle So as the particle is going here, at some instant, this will be the speed v, and this is alpha. So here, alpha, we can write tan alpha is vertical velocity by horizontal velocity. This comes from vectors. U sine theta minus gt by u cos theta. Alpha is simply angle between v bar and the horizontal. The third thing, if you see, the horizontal velocity is always constant. That means the horizontal velocity v cos alpha is equal to u cos theta. Just give me a minute. Let me take the attendance. Some people are missing. Who got disconnected, right? Great. So v cos theta is equal to u cos alpha. So these are some pretty good results. And one more thing, if you see here, few things. At h max, velocity is not zero. Be careful. This is the general thing, right? Maximum height away velocity is zero. It is not zero. At h max, vy is zero. The speed is still u cos theta. So in a projectile motion, you don't stop at the maximum point, right? So speed is u cos theta, or velocity is u cos theta I cap. Perfect. There, that's your all your velocity profile, and that's your all your equations. Let me put down the entire thing in one page so that it will be easy for you to refer. So if you project a particle with u and theta, you go up and then you fall down somewhere here. So let's say at this instant you're at x comma y. Your velocity is v bar. This is your angle alpha. So from here to here is your r bar, the position vector. The first thing, the position vector r bar. Most people don't remember these things and they mess up even easy equations. What is x coordinate? We derived it u cos theta into time. You can note down these things. Write it down with me. Like you will need it for the next 2 classes almost. U sine theta t minus half gt square. If you already know, then it is fine. But if you have no idea or if you think you're confused, you can note it down. Velocity v bar is vx I cap plus vy j cap. U cos theta I cap and u sine theta minus gt j cap. That gives you the velocity and the position. Y is equal to x tan theta minus gx square by 2u square cos square theta, or x tan theta 1 minus x by r. H max is u square sine square theta by 2g. Time of ascent is equal to time of descent is equal to u sine theta by g. You know when they will not work, so I'm not writing that. Time of flight is 2u sine theta by g. Range is u square sine square theta sine 2 theta by g. Tan alpha is u sine theta minus gt. by u cos theta. V cos alpha is equal to u cos theta. You want to find the speed as function of time t? You can do that also. So mod v, magnitude, will be root over vx square plus vy square. So you can get the speed in terms of time or angle alpha. There. These are all your basic formulas in the projectile. All clear with this? Let's do one small practice problem, and we'll see more in the next class. But that's all your theory there. Should definitely go through this. That's a bit of a theory, but technically that is all the concept in projectile. So the main idea is that you split the motion in the x and y axis and you finish it off. The idea is this: tomorrow, if you're throwing particles in 3-dimensional, you do the same thing. You split the motion in x direction, y direction, and z direction, and then you study each one separately, get your x, y, z coordinates, and then you add it up. So you do handle such kind of things. So things do happen. So then you should not think like, oh, this is looking new. So you should simply say principle of superposition. It works. So yeah, let's see some one basic question. Particle is projected with 20 meters per second at an angle of 60 degrees. Gravity is 10 meters per second square. Find h max, range and time of flight. Standard formulas. Find time and speed at h max by 2. Find time when b bar makes an angle 45 degrees with x-axis. Find speed when particle makes angle 30 degrees with horizontal. Okay, let's get them all. These are all are formula based. There is nothing to think. You just need to put your formulas and get them. Try. I'll give 2-3 minutes. Yeah, H max part is fine. Get the B part. That's what I'm more interested in. First part, everyone will get it. Get the B part. This is a brute force. Okay. Speed is something. That might be right, Yukti. Finish off, finish off. It's an easy one. Yeah, speed is right, Rohit. Slope, that is wrong. Okay. Let's see the first part. That was the easy one. H max u square sine square theta by 2g. This is 400. Sine square 60 is 3 by 4, and this is 20, and that's 15 meters. Time of flight is 2u sine theta by g. That's 2 into 20 by 10 into root 3 by 2. That's 4 root 3. 40 by 2 to root 3. The range is u square sine 2 theta by g. The u square is 400, g is 10, and that sine 120 is again root 3 by 2. That's 20 root 3 meters. I hope that was clear. That was straightforward. Next thing, B part. You want to find the time and the speed at h max by 2. Yeah, let's try to understand. Always, whatever question is given, first get the data, mine the data first. What is given? You gave y coordinate. Y coordinate is h max by 2, which is 15 by 2 meters. Great. What is uy? 20 sine 60. That's 10 root 3. Perfect. What is ay? Minus 10. Time, I don't know. That's what I have to find. Vy, I don't know. Great. See, now it is clear. What data do I have? I know uy, ay, everything you're asking for y coordinate. So basically, this is your sy if I write this way. So sy is equal to uyt plus half ayt square. Since you're talking about heights, don't talk about x coordinate. Na? Horizontal direction will never give you height. So it is clear you're just studying the vertical motion here. So substitute here. This will be minus 15 by 2 plus 15 by 2. Uy is 10 root 3t. And then this will be half 10t square. Yeah, numbers don't look really that great. So yeah, solve this 5t square. That will be t square minus 2 root 3t plus 3 by 2. And this will give you t is equal to 2 root 3 plus minus root over b square 12 4 3 minus 6 by 2. Simplify this, and that would be root 3 plus or minus root 6 by 4, that is root 3 by 2. That's your answer. Again, you got two answers. Why did you get two answers? Because you simply asked, find the time when you reach h max by 2. This was your h max. There are two times you will reach h max by 2. One while going up, one while coming down. So that's why you're getting two answers. So this was root 3 minus root 3 by 2. And this was root 3 plus root 3 by 2. Are you clear how we approach this? So the question, right, indirectly ये हो गया question. The particle is thrown up with uy. Find the time when it reaches h max by 2. Didn't we do a question like this? Just because it is projectile, don't get confused. You are asking anything in vertical direction, only bother about SY. Horizontal will not matter. Everyone clear with this, how we approached it? Right? So yeah, the time is not great. What about the speed? Same thing. Vy square minus uy square is equal to 2ay sy. Just put a y everywhere. So this will be Vy square. Uy square is how much? 10 root 3. Ay is minus 10. It is down, and Sy is 15 by 2. So this will give you Vy square is 300 minus 150. This is 150. Now be careful here. And what is Vx? Vx is u cos 60. You're asking for speed. This is a mistake people do. They just find Vy or Vx. So speed V is nothing but you have to take both the components. Speed V is root over Vy square plus Vx square, which is root over 150 plus 100. That's 5 root 10. So be little careful with the speed ka part. Most common mistake people find Vy or Vx and then they forget about the other one. Everyone clear what we did? So if you see what we did so far, right? You're studying vertical separately, horizontal separately, and you're just bringing them together. That was the easy part. CNDR, find time when it makes 45, find speed when it is 30. Again, which formula to use? Ask yourself, what am I asking you? Find angle when you make 45 degrees with ground. Okay, now angle ke liye there are only two formulas. Tan alpha is u sine theta minus gt. That is how you should always think. What are you asking and what formulas are involved? What is the other formula? U cos theta is equal to V cos alpha. That's it. These are the only two formulas you have. And you're asking for time. This is the only formula with time. Can you think of any other formula where alpha was there? Alpha was there only in these two formulas. See, that is how you retrieve. What do I know and where do I exist? And then you're done. So this tan alpha, you said 30 degrees. Now you didn't say which 30, yeah? So I'll have to take plus or minus 30 because it could be going up or coming down. U sine theta is 10 root 3 minus 10 t by 10. So this would be plus or minus 1 by root 3. This is root 3 minus t. So we get t is equal to root 3 plus or minus 1 by root 3. Again, the reason you got two answers is because that vague statement, 30 degrees with horizontal. Which 30? While going up wala 30 or coming wala 30? So we should take plus or minus 30 since there are two possibilities. And the D part was the easiest. Find the speed when the angle was 45. Yeah? Oh, wait, I did a mistake here. I wrote 30. I'll just change the question. This is 30, this is 45. I did a mistake. Clear? I took it here as that this is supposed to be 45. So you will get root 3 plus or minus 1. I'm lazy to change it, so I change the question. So yeah, this is 20 cos 60 is equal to V cos 45. There, straightforward answer. V by root 2, so V is 10 root 2. If you just want speed, and you know the angle, you get this thing. This is a very useful one, very useful one. You will see this in multiple places. Meaning if I have to show you at one place, and no one will ask you a question like this in the exam. The question would be something else. Look at this question. So we have a water jet from a building. The water jet, when it goes, you ever seen a water jet? The area changes. So the water jet is flying like this and it is falling on the ground. So this is a projectile motion. So if you see, we use this formula. Horizontal velocity is constant. So questions would be something of this sort. No one will ask you the question directly. So what are we learning is like the basics. Think of like this. You're making a biryani. We are just cooking rice. Biryani abhi tak hua nahi. Anyway, so that's how we get our basics clear. Clear with this? So on Wednesday, when we catch up, we'll continue from here. Next class, we'll do some really good problems on projectile. We have much variations. I think this will take 2 classes more. We will wrap up with projectile, then we'll go for relative motion and graphs. So that would be the there. But projectile is the most important thing on the entire kinematics. Okay, with that we'll wrap up for that day. I'll see you guys on Wednesday again, same time. So there is a test online till Friday, so make sure to give it. And you can start doing kinematics 1D is complete. So if you're doing HCV, I think you can start doing the first 30-40 questions. Or if you're doing your booklet or your classes ka material, please start doing 1D part. Finish off by next Monday. Take a 1 week time and finish your 1D motion. Right? So okay. So any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you guys again Wednesday. So take care, stay safe.